As VPN multiplexer is the term we use to indicate the following scenario: that a machine is with multiple instances of site-to-site VPN. In the diagram below, FWA and FWB are connected via site-to-site VPN so that the LANs behind them can see each other. In the meanwhile, FWA and FWK are also connected with site-to-site VPN on another UDP port. In this case, we say that FWA is as VPN multiplexer. The operation principle is that we have multiple instances of site-to-site VPN running on FWA with different UDP ports. For adding extra instance of site-to-site VPN as TLS server, it can be done via VPN site-to-site multiplexer. And you should use different UDP port, tunnel IP addresses, and different LAN address for the network inside FWK. On FWK, it needs to be configured as TLS client on the UDP port chosen by FWA. HC 1.2.3. FW4K FWAD 192.168.9 H 9.1 E 192.168.9 G 9.2 192.168.2.0 FW/24B F 1.2.3 5192.168.3.0/24. The easy way to view this diagram is, from FWA, red tunnel is to FWK and blue tunnel is to FWB. Blue tunnel is using UDP port 7777 so that red tunnel should use different UDP port. Those are the basic modes of VPN provided in the software package. It also allows the combination with different modes on one server. Currently, the following combinations of mixed modes are allowed on the same server. When site-to-site VPN is turned on, you only can configure it as TLS server or TLS client. But site-to-site TLS server and site-to-site TLS client are not allowed to run on the same machine at the time of writing this document. And while running as site-to-site TLS server mode, you can have multiple instances running by using different UDP ports. While using site-to-site TLS client, for simplicity's sake, only one instance is allowed to run. It should cover most of the basic application of VPN with the combinations of mixed modes. As a matter of fact, it is possible to configure a machine with site-to-site TLS server and site-to-site TLS client together on the same machine via console command line interface in theory. But we try to avoid that in WebGUI. It would easily bridge the nodes that should not connect to each other or cause network address conflict while they are under different admin people or organizations. We provide the following examples of network connection via VPN so that you might adapt them while doing network planning. Example, servers at different locations connecting to headquarter. You have several servers in different locations. Those servers can be accessed via some group of people. In the meanwhile, the servers have to send data to a central place. This is a scenario that would be used so often. Data sent via public network need to be encrypted. If the encrypted mechanism does not exist in the application itself, you can consider just send the data over VPN. Since the machine with Azblink software package can act as mobile-to-site client, we can have the following network diagram. In the diagram below, server B, C, and D can be configured as mobile-to-site VPN client and firewall FWA can be configured as mobile-to-site VPN server. So, B, C, and D can access the super server E inside the firewall. However, the clients of B, C, D do not have the chance to follow the VPN link to Tracy. BDC FWA LAN E inside FWA site CBA FWAB. Example, site-to-site VPN plus mobile-to-site VPN in the diagram above. Everybody at site A needs to access the machines located at site B. So, FWA and FWB can set up a site-to-site VPN connection. In the meanwhile, some people traveling outside the office would like to connect back to their office at site A. At this moment, a mobile-to-site VPN server can be started at FWA. Thus, FWA has two modes running, site-to-site VPN and mobile-to-site VPN server. PPTP VPN PPTP is phased out now because it is not secure. For historical reasons, we still keep it for compatibility purpose. But you should avoid using it. PPTP stands for point-to-point tunneling protocol. That is another method to implement VPN. It is a different VPN protocol from what we introduced in the previous sections. PPTP is less secure compared to OpenVPN, but it is easy to use and its client is shipped with Microsoft Windows and some smartphones. In our system, PPTP shall not be used when PPPoE is activated. And we do not encourage the large-scale use of PPTP if you have performance issues. Conceptually, PPTP is similar to what we have for OpenVPN. You are asked to specify a class of IP addresses for the use of PPTP VPN. One will be used for the IP address of PPTP server inside VPN, and the other IP addresses will be used for the PPTP clients. The setting can be done via VPN PPTP IP addresses. As shown in the screen snapshot, we have local IP address, 172.16.45.1 remote IP addresses, 172.16.45.101-110 number of connections, 10 PPTP server will use the local IP address, and the remote IP addresses set from 172.16.45.101 to 172.16.45.110 will be assigned to PPTP clients. Please notice that there will be a lot of virtual Ethernet interfaces, E.G, PPP0, PPP1, PPP2, created when PPTP clients are connecting to PPTP server. Those virtual Ethernet interfaces will be added to zone road in our border control rules border reshuffle zone setting automatically. Check the entry in the diagram above road PPP plus to indicate PPP0, PPP1, PPP2, are added into zone road. This is the reason why you shall not use PPTP when PPPoE is activated. PPPoE will use PPP0 and PPP0 will be set to zone net when you use it to connect to your internet service provider. There exists rule conflict when you use PPTP and PPPoE together unless you want to manually override those rules. A PPTP client is required to enter user account and password while establishing connection to PPTP server. Those user accounts can be set at VPN PPTP users. And you can associate an IP address to an account so that using that account in PPTP will always get the same IP address. PPTP is using TCP port 1723. So, you have to make sure TCP port 1723 is open for access even after you launch PPTP server. And you might require to set extra routing entries on your PPTP client's routing table if you need to use it as a gateway to the other networks. VPN in bridging mode. We also provide VPN in bridge mode. As we mentioned earlier, both VPN server and VPN client will have virtual Ethernet interfaces created respectively after VPN process is launched. The virtual Ethernet interfaces created in VPN server side are shown as TAP-N, e.g. TAP0 and TAP1. It does not make sense to run VPN server alone in bridge mode. You have to add the virtual Ethernet interface, TAP0 and TAP1, into an Ethernet bridge that consists of other real Ethernet ports. Thus, the VPN clients can be viewed as appearing in the subnet of that Ethernet bridge. There are some useful scenarios for running VPN in bridging mode. However, it has drawback that it is not scalable when you put a lot of users in the same subnet. Thus, it is not intended to use it when you have many VPN clients. It is usually to let both sides of the VPN fall into the same subnet. The key management for VPN bridging can be found via VPN bridge key management. The process is similar to what we have previously: create CA, create server certificate, and create client certificate. And please note that the common name for each needs to be unique as well. And to set it as VPN bridge server or VPN bridge client, it can be done via VPN bridge server/client. If to set it as a server, just click the checkbox acting as VPN bridge server and set the server UDP port. For example, check acting as VPN bridge server UDP port 1195 cipher, AES 128 CBC. And press submit. Enable start VPN bridge process, ES, on the right. To run it as a client, you have to submit the certificate issued from the server. And for example, you can have the following settings: server UDP port 1195 server IP address 192.168.11.201 cipher, AES 128 CBC. We have a scenario diagram to use this technique: site-to-site VPN in bridge mode. In the diagram above, 3 machines with their WAN ports on the subnet 192.168.11.0/24, for example. You might consider the 3 machines sitting in different places on the internet as well. The real issue is, they would like to bridge 3 LAN ports of the 3 machines together. In this case, site-to-site VPN in bridge mode is used. The 3 LAN ports are placed into the subnet 172.16.35.0/24. Please note that all the LAN side networks of the 3 VPN gateways belong to the subnet 172.16.35.0/24. And 2 remote routers are in the subnet so that the 2 routers can exchange routing information from this mechanism.